When we teach our students how to solve for the circumference of a circle, we often just teach them that the formula is c equals 2 times pi times radius. Or in other words, pi times diameter, because we know, if we look at this picture, that the radius is 1/2 of the diameter. But often students don't know where the relationship between the radius and the diameter and the circumference come from. So in order to understand this better, we're going to assume that students know that the diameter is 2 times the radius, and we're going to look at the relationship between the circumference and the diameter. We're going to do this using Fathom. So if I open up a Fathom document, and I want to create a new collection, so I'm going to drag that on. If I right-click, I can make 10 new cases. Now I want to look at them in a table, so I'm going to pull down a table, make it bigger, and you can see my 10 cases on the side. So I'm going to label the first attribute radius. I'm going to name the second attribute diameter, and the third circumference. I can make this column bigger so that you can see it. So if I go up here and I right click, I can show units, and I want my radius in centimeters. I want my diameter in centimeters, and I also want my circumference in centimeters. If I right click again, I can show the formulas. So if I double click on my diameter formula, we're going to assume that our students already know that the diameter is equal to 2 times the radius. And I can click enter. And we're going to assume, in terms of diameter, that our circumference is pi times the diameter. And we're going to push enter. So now I'm going to start over here, and I'm going to go up by 2, starting with the radius as 2 centimeters. So we're going to keep going. 4, 6, 8, 10, 12, 14, 16, 18, and 20. So if I stretch that out, we can see, using the formulas, that the diameter is 2 times the radius, and their circumference is pi times the diameter. But I want to see how they're related within a graph. So I'm going to drag down a graph, and I'm going to drag circumference as my vertical attribute, and diameter as my horizontal attribute. And you can see that they're in a linear line. So now one thing I can do to my graph is I can go up here to graph, and I can add a movable line, and it adds one to my graph for me. But I don't want this to move from the origin. So if I go back up to graph, I can lock the intercept at 0. So it moves my line down to 0. And then I can best fit my line by moving it like so. So it seems like when we look at our equation down here, that circumference is equal to 3.14 times the diameter. Now I want to see an exact number. So if I go back over to my table, I can add another attribute in order to see the relationship between the circumference and the diameter. So if I go circumference diameter, I can add a formula, and I can say that it's equal to circumference divided by the diameter. If I push enter, I can see down here that all of my values remain constant. No matter what the radius is, what the diameter is, or what the circumference is, the relationship is always the same between the circumference and the diameter. So I can pull down a summary table and drop in the circumference diameter as my attribute. So it says the value is 3.14159, or exactly pi. So then we can go and do this algebraically on paper to make sure that we're right. So we said that the circumference diameter, or circumference divided by diameter, is equal to pi, which is what we just found in our summary table, and by doing it in our own table. So if we want to solve for circumference, we multiply by the diameter so that circumference is equal to pi times diameter. Now we're assuming that our students know that diameter is equal to 2 times radius, So we can substitute that value in and rearrange it so that circumference equals 2 times pi times radius, which is what we teach our students at the very beginning when we teach them. But this way, by doing it using Fathom, they're able to enter their own formulas and see the relationship through tables, graphs, a movable line, and a summary chart.